Hi guys, so Devjit this side. I'm a software developer with 6 plus years of experience as a Java developer. So in this video, I'll be discussing about a recursion problem which is nth Fibonacci, which is very much asked in the interview. Okay, frequent question. So let's get started and try to understand how nth Fibonacci works through recursion. So what is the Fibonacci series that we have to understand first? The Fibonacci is 0, then 1, then 1. So how it is working here? So if we can closely observe, 0 and 1 we are adding and we are getting the next element, which is 1. Okay. Then 1 and 1 are getting added and we are getting the next element. Then 1 and 2 are getting added and I'm getting the third element. So like that we will get the n numbered Fibonacci series. But let's suppose I want to know what is the nth element of this Fibonacci series. So I want to calculate what is the fourth Fibonacci element present. That means nth Fibonacci means I am considering n as 4. So 4 means 0, 1, 2, 3, 4. This is the fourth Fibonacci element, which is 3. Okay, so I need to print it using recursion. How can you print it using recursion? Let's understand that. So first of all, we need to see if we need to know the first two elements. First two elements should be known to us first. So that is A and that is B. Okay, so let's suppose I want to know the element this, which is Fibonacci of n, and to know this, let's suppose n is at 2. Okay, second index. So we need to know n minus 1 as well as n minus 2th index. So we need to break a big problem into a small chunk of problem. That is the recursion, right? Recursion is nothing but a relation between bigger problem and a smaller chunk of problems. So let's understand this. So Fibonacci of n will be equal to Fibonacci of n minus 1 plus Fibonacci of n minus 2. You're understanding, right, why I have written like that? Fibonacci of n I'm considered as this number, which is at second index. Okay, so it is the addition of 0th index plus first index. So like that it will be having in the entire series. So how can we implement it using recursion? So we will write one Fibonacci series, Fibonacci method. Okay, and it is expecting n, and n is nth Fibonacci element. So I am expecting n here. Okay, and within this what we will do? What is the base case scenario here? So base case will be till what time this Fibonacci will be added? Till n becomes 0 or n equal to 1. Okay, so let me try to make you understand through recursive tree diagram how it is working. So but before that, let me complete this method. So first is the base condition, because below n equal to 0 and 1 it should not go, right? So if n is equal to 0 or n equal to 1, if this is the case, then what we have to do? We just have to return n. We will be returning the n. Okay, so if n is 0, we will return 0. If n is 1, we will return 1. Why we are doing like that? We will be understanding it, okay, in some time. So here, if n is not 0, n is not 1, then what we have to do? We will return, what we will return, guys, here? If you understand this function relation, that we will implement it here. We will just do return Fibonacci of n minus 1 plus Fibonacci of n minus 2. That means there is two recursive tree structures are present over here. Fib of n minus 1 is one recursive tree structure, linear tree structure, and fib of n minus 2 is another linear tree structure. So now let's understand through the linear tree structure how it is working. So let's suppose this n equal to 0, 1, 1, then 2, then 3, then 5. I want to know the fourth index. So 1, 2, 0, 1, 2, 3, 4. I want to know at n equal to 4, it should come as 3. How it will come as 3? So first I will take it as 3. That is Fibonacci of 3 here. Okay. And to calculate the Fibonacci of 3, how will we calculate Fibonacci of 3? We will break it into smaller problems. Okay. We will calculate Fibonacci of 2 and Fibonacci of 1 here. So now here Fibonacci of 1, you can see the base case condition is hit now. N is equal to 1. So this will return me what? N. So n is 1. So it will return me 1 here. Okay. So here Fibonacci of 2, what I will do? It will still be break into two parts, right? Fibonacci of 1 and Fibonacci of 0. What is 0 and 1? We have hit our base case scenario, right? So for 0, we will return 0. For 1, we will return 1. So it will return me 0 and here it will return me 1. So if we add these two, 0 plus 1, here fib n minus 1 plus fib n minus 2 we are doing. So 0 plus 1 is 1. and here fib of 1 is returning me 1 only. So 1 plus 1 here is, it will return 1, it will return 1, so 1 plus 1 is 2. So like that we will be calculating. Okay, so this is the entire structure here. Okay, so this is the third index. Like if I am checking here 0 1 2 3, so here at fib of 3 it is 2. Okay, so we have calculated, right? So this tree structure will be working like this. So it will first go with linear structure once, it will go 3 2 1 like that, and then next fib n minus 2 will work. Okay, so 3 minus 2 is 1, and fib of 1 we already know, it will return me 1. So like that the Fibonacci and Fibonacci we can calculate. And if we try to understand through stack structure, that also we can understand. If we see through stack structure, first main method will come. Okay, after main method what will come? It will call this fib method. Fib will be having, let's suppose 3. Okay, and this fib 3 method will check if n is 0 or 1. No, n is neither 0 nor 1. So here it will come here, a fib of 2. Fib of 2 plus fib of 1. Okay, so first it will do fib of 2. Okay, plus fib of 1. So fib of 2 is what? Fib of 2 is nothing but fib of 0 plus fib of 1. And here it is fib of 1 is 1 only. So fib of 0 plus fib of 1, what it will return here? After 0 and 1 it has hit our base case. So fib of 0 means 0, fib of 1 is 1. So it will return me 0 plus 1, which is 1 here. So here fib of 0 plus fib of 1 is fib of 2. Now fib of 2 will be replaced with 1. So 1 plus fib of 1, fib of 1 is 1 only. So 1 plus 1, it will return me 2. Okay, and fib of 3 is 2 now. So 2 is returned to main method, and main method is returning me 2. Okay, so like that through stack also we understood how fib of 3 is coming as 2. So I hope you got an understanding and clarity like how Fibonacci and that Fibonacci element is working here. Okay, so let's do dry run by yourself and you will also get a better picture clarity. So until unless you write down the code and try to understand it, you will not get it. Okay, so theoretically you understood, practically also you have to do it by yourself. So this is the code I have explained you through stack structure, and I have explained you through tree structure, recursive tree structure as well. So there is a recursive leap of faith. If you have that confidence, there is no need to calculate this. This is automatically gets calculated internally through recursive leap of faith. Okay, so till then we will meet you with a new problem statement. Till then, keep on practicing, keep on learning. Bye bye.